We already said about the definition and the PDF of Chi-Squre invariant. Okay, and the definition of Chi-Squre invariant is given by sum of square of n mutually independent normal 0 1, that is standard normal, is Chi-Squre invariant. We define this in previous lecture. Okay, and here in this lecture we prove it. How do we say this is Chi-Squre invariant if we make the sum of the square of n mutually independent normal 0 1. Okay, to prove this theorem or this definition of Chi-Squre invariant, we use the principle of mathematical induction. Okay, so we first let for n equal to 1. Before taking n equal to 1, let x1, x2 to xn are mutually independent normal 0 1. Normal 0 1. And we have to prove x1 square plus x2 square plus 2xn square is Chi-Squre invariant, right? Sorry, Chi-Squre invariant, Chi-Squre n. And we know that for the principle of mathematical induction, let first n equal to 1, and in this case we get x1 square, and since here only one random variable, so we can take this is y, this is equal to x square. We write x square in place of x1 square. Okay, and let capital F of y be the CDF, and this is known as distribution function of the random variable y. Okay, here x is normal 0 1, so spectra of x is obviously given by minus infinity, less x, less infinity, right? And this implies that the spectrum of y, this is equal to x square, is clearly 0 less than y, 0 less than y, less than infinity. This is the spectrum. Okay, now we try to find out the CDF or distribution function of y. How to find out CDF? If y less than 0, okay, or we get y less equal to 0, then capital F of y, this is equal to 0, because there is no point in the spectrum which are less equal to 0. And now if y is greater than 0, then we can write the definition of CDF. What is the definition of CDF? We write here, the definition of CDF is this. Okay, so f of y, this is given by y less equal to small y, and we write probability of y is this, y is x square, so x square less equal to y, and this gives that probability of mod x less equal to root y, right? And this implies probability of minus root y less than capital X or it may be less equal to root y. Okay. Now we use the property of probability, which is given by this is integration minus root y to root y. This is fx dx. Sorry, this is not fx dx, this is phi x dx. What is phi x? Phi x is the PDF of x. Here x, we say here x, every x, that is x1, x2, xn are normal 0, 1. And generally the PDF of normal 0, 1 is denoted by phi of x. And what is the PDF? We write already here. The PDF of phi of x is this. So we put the value here minus root y to root y. This is 1 by root 2 pi e to the power minus x square by 2 dx. Okay. And also we use here an important property of CDF and PDF. That is the relation between distribution function and probability density function, which is given by this. This is distribution function and this is the derivative of distribution function, and this is becomes PDF. So we must differentiate this f dash y and getting the value of fy. This is the PDF of y, and which is given by how to differentiate it. We first, before going to differentiation, we write here one line. This is an even function, so we write it 2 into integration 0 to root y. This is 1 by root 2 pi e to the power minus x square by 2 dx. Now we differentiate it. Okay, and the derivative of this integration is given by, we write first the constant term 2 by root 2 pi. Now we put the upper range in the integrate first. This is given by e to the power minus y by 2, because x is root y, so x square is y. And the derivative of upper range, this is d dy of root y minus, this is obviously 0, because if we put 0 in place of x, this is e to the power 0, this means 1, and into d dy of 0, that is the lower range, so it must be 0. And this is given by root 2 by pi into e to the power minus y by 2, and this is given by 1 by 2 root y. Okay, and cancelling this root and this root, we get e to the power minus y by 2 into y to the power minus half, because this is root y, and the lower term is given by root 2 into root pi, and we put the value of root pi. This is gamma half. Gamma half is root pi, we know. Okay, so we write this is given by e to the power minus y by 2, and this is y by 2 to the power half minus 1, because this is minus half, so it can be written as half minus 1. Okay, and we adjust this 2 to the power minus half in denominator, this is 2, and this is gamma half, because we know that root pi, this is equal to gamma half. Okay, now if we see the PDF of Chi-Squre n, what is the PDF of Chi-Squre n? The PDF of Chi-Squre n, we know that this is given by fx, which is 1 by 2 into gamma n by 2 into e to the power minus x by 2 into x by 2 to the power n by 2 minus 1, where x greater than 0. So comparing with the PDF of Chi-Squre n, we say that here this is 1 and this is also 1 in place of n. So we say that f of y is the PDF of Chi-Squre 1. Okay, and this implies that y this is equal to x square is Chi-Squre 1 variate. Okay, so if we take only one normal 0 1, then the square of this normal 0 1 becomes Chi-Squre 1. So by the using rule of principle of mathematical induction, we let that x1 square plus x2 square to xm square is Chi-Squre m, and let it be u. Okay, now x1 square plus x2 square to xm square plus xm plus 1 square, and let it be v. Now we have to show that this v is Chi-Squre m plus 1, and by showing this is Chi-Squre m plus 1, we prove by principle of mathematical induction, since this is true for n equal to m, so this is also true for n equal to m plus 1. Okay, and in this case we say that by using this principle, x1 square plus x2 square to xn square is also Chi-Squre n variate. Okay, now we start to prove this step of principle of induction. Okay, we let that this is not v, this is y. Okay, and we take v, this is equal to the last variable, this is x m plus 1 square, and we already proved this is the square of one standard normal variable, so this is given by Chi-Squre 1. Okay, so we get here y, this is equal to u and this is equal to v, so this is u plus v. We also let that this is z equal to v, because we cannot transform the random variable, two random variable to another one random variable, so we must have to take another one random variable and let this be z. And in real variable we get this is y, this is equal to u plus v, and this is z, this is equal to v, and we get u, this is equal to y minus z, and v, this is equal to z. Now we first find out the Jacobian of the transformation. What is the Jacobian of the transformation? We first find the Jacobian as del uv by del yz. Okay, and this is determinant del u by del y, del u by del z, and the second row is del v by del y, del v by del z, and this is given by del u by del y, this means 1, del u by del z, this means minus 1, del v by del y, this is 0, del v by del z, this is 1, so this is 1 and this is greater than 0. So it keeps the constant sign, and since here x1, x2 and xn all are independent, so we say that here y and z must be independent. Okay, because y and z are formed by the independent normal variate. Okay, so our PDF of yz is given by gyz this is equal to FUV into Jacobian of UV to YZ. Sorry, this is YZ. And so this is F of UV because this is 1. Now we have to find first the PDF or joint PDF of UV. We know that joint PDF of UV is given by, here we write FUV. This is FUU into FVV. These are the marginal PDF of U and V. And what is the PDF of U? PDF of U is nothing but the PDF of Chi-Squre M. And we write that Chi-Squre M is e to the power minus U by 2 into U by 2 to the power M by 2 minus 1 by 2 into gamma M by 2. This is the PDF of U. And also the PDF of V, this is Chi-Squre 1. So we get e to the power minus V by 2, V by 2 to the power half minus 1 by 2 into gamma half. Here obviously U, V both are greater than 0. We put the value of FUV in place of here. So we get GYZ. This is equal to 1 by 4 into gamma M by 2 into gamma half into e to the power minus U plus V by 2. This is this is this. Okay, and this is U to the power M by 2 minus 1 and this is V to the power minus half by this is given by 2 to the power M by 2 minus 1 and here also 2 to the power half minus 1. So this is plus half minus 1. Okay, and we have to change UV to XY because this is the PDF of YZ. Sorry, this is not XY, this is YZ. Now what is the value of U? U means Y minus Z and V means Z. We put here. So we get the result as 1 by gamma M by 2 gamma half. And this is 4. 4 means 2 to the power 2. So we add the power of 2 together and getting the result as 2 to the power M plus 1 by 2 because 2 and 2 cancel out. Okay, and this is e to the power minus U plus V. U plus V, this means obviously Y. So this is Y by 2 and U means Y minus Z to the power M by 2 minus 1 and V means to the power Z to the power minus half. And here the ranges are given by U greater than 0, V greater than 0. So we write Y minus Z greater than 0 and we write Z greater than 0. So the combined range can be written in the form as 0 less Z less Y because from here we get Y greater than Z. Right? So 0 less Z less Y and also we get Z greater than 0 or we write in this range. Okay, so we get the PDF or joint PDF of Y and Z. Now we have to find the PDF of this. This is Y, which is given by U plus V. So we must have to find out the marginal PDF of Y from here. How to find out the marginal PDF? To find the marginal PDF of Y from the joint PDF of Y and Z, we must have to integrate. This is GYY, which is our required answer, is given by this is minus infinity to infinity and this is G of YZ, this is DZ. We must have to integrate with respect to Z. Okay, now we put the joint PDF from here. So get the result as this can be written in the outside of integration, which is given by 1 by gamma m by 2 gamma half 2 to the power m plus 1 by 2. And the range of z is this. So z, this is equal to 0 to y. And we put the value here, e to the power minus y by 2, and this is y minus z whole to the power m by 2 minus 1, and this is z to the power minus half dz. Okay, and here in the integrand the term y is treated as constant because we integrate with respect to z. Okay, and put z, this is equal to ty, and obviously dz, this is equal to t dy. Sorry, y is constant, so y dt, and the ranges also change. Here we get that e to the power minus y by 2, we write this term also outside the integration because y is constant with respect to z, by gamma m by 2 gamma half 2 to the power m plus 1 by 2. This is integration. When z equal to 0, then obviously t equal to 0. When z equal to y, then obviously t equal to 1. And this is given by y. Y means y minus z. Z means ty. So we write y minus ty to the power m by 2 minus 1 into z. Z means ty to the power minus half, and dz means y dt. Okay, now also we write the all terms of y outside the integration. We get that e to the power minus y by 2. From here we get y to the power m by 2 minus 1, m by 2 minus 1, and from here y to the power minus half. So this is also minus half, and this is also plus 1, and we get in denominator is gamma m by 2 gamma half 2 to the power m plus 1 by 2, and this is t equal to 0 to 1 minus t equal to the power m by 2 minus 1, and t to the power, we again write this is half minus 1 dt. Okay, now we know that the PDF of beta 1 LM, which is given by fx, which is given by 1 by beta LM into x to the power L minus 1 into 1 minus x to the power m minus 1, and the range is 0 less x less 1. So it is clear from this PDF of beta 1 LM, if we integrate from 0 to 1, this integration, this is 1. So we get this integration by using directly from the PDF of beta, or it also be beta function. We write that e to the power minus y by 2, y to the power, this is m plus 1 by 2, okay, by gamma m by 2 gamma half 2 to the power m plus 1 by 2 into, this is nothing but beta function, beta m by 2 comma half, because here L is m by 2 or half and m is m by 2. Okay, and we know that beta Lm, this is equal to beta ml, and also we use the formula, that is the relation between beta and gamma, which is given by beta Lm, this is gamma L gamma m by gamma L plus m. Okay, so if we put here the value of gamma, okay, we get that this is, we subtract it from here and write the value, this is gamma m by 2 gamma half by gamma m plus 1 by 2. obviously this cancel out. Okay, so we get the PDF of y as we write here GYY, which is given by, this is e to the power minus y by 2. This is given by y by 2 to the power, y by 2 to the power, this is m plus 1 by 2 by, this is gamma m plus 1 by 2. Right? We make a silly mistake here in the calculation of the power of y. When we taking common y from this integration, we get y to the power m by 2 minus 1 minus half and plus 1. Okay, and calculating this, we get the result as this is m plus 1 by 2, but this calculation is not gives m plus 1 by 2. This is obviously 1 cancel out, so m minus 1 by 2. Right, and write it here, we get the result as m minus 1 by 2, and the range is y greater than 0. So if we write this PDF as e to the power minus 1 by 2 into y to the power m plus 1 by 2. So if we write this PDF as e to the power minus y by 2 into y to the power m plus 1 by 2 minus 1. Okay, m plus 1 by 2 minus 1, then we get 2 to the power m plus 1 by 2 minus 1 into 2 here, because 2 to the power minus 1 and 2 to the power 1, this means 2 to the power 0 into gamma m plus 1 by 2, where y greater than 0. And this relation gives that e to the power minus y by 2 into y by 2 to the power m plus 1 by 2 minus 1, because the power of 2 and power of y both are same, by 2 into gamma m plus 1 by 2 and y greater than 0. This is the marginal PDF of y, and this is nothing but Chi-Squre m plus 1 variate. Okay, so we say that y, this is u plus v, is Chi-Squre m plus 1 variate, where this is the sum of the square of m plus 1 independent standard normal variate. So by using principle of mathematical induction, we say that this, for any integer n, this is Chi-Squre n. Okay, very interesting but long theorem. Okay, thank you for watching.